Geographers, how are you doing? Welcome to yet another GIS video. This one is not leading you through an exercise for the week, but rather what I want to do here is get a little more theoretical, as well as show some practical applications within ArcGIS. But I want to talk about, and at least introduce this concept of geoprocessing. And geoprocessing, yet another one of these terms that we have where we take a perfectly normal word, we stitch geo onto the front of it to sound more special, scientific, whatever. But really what we're getting at, when we use this term geoprocessing, is that we're looking at analyzing geographic data, spatial data in some way, and taking our analysis further than we have in these previous weeks. And this is other stuff that we've done. We're really getting into and manipulating, comparing, altering, whatever, these different types of data, these different feature classes, the layers that we have right here in our contents pane. And so what I've done to discuss this and to introduce this concept is I've put together this little file geodatabase just called Geoprocessing. It's available in Canvas, and I just threw some things in here for us to play around. You are welcome to download this and play along, but there's nothing in here that you're actually going to be turning in. There's no exercise connected to this. I have something separate for this week and in some future weeks, because we're going to work with this concept of geoprocessing over the next handful of weeks, because there are a lot of different ways we can do this, a lot of different ways we can manipulate and analyze geographic data. Okay, so that's the plan. Now, the first thing I want to really stress here is that before we do anything, we need to do a little, foundational groundwork to ensure that our analysis is going to be solid. And it's going to be as accurate as it possibly can be. And so with that, the very first step before you do any kind of geographic analysis is we want to make sure that our data are projected into what Esri is going to call a projected coordinate system. And not only that, but that every single feature class we have here is in that same projection. Okay? Now, when I start talking about coordinate systems and projected coordinate systems, it's the kind of deal where we've seen this stuff. I've had you change it here in the map properties box, and you can see everything that I've given you. It's on this WGS 1984 system. It's a geographic coordinate system, one of these here. Perfectly fine for data storage and sharing and all that, but when it comes to analysis, we don't want to leave this here. Right? So we need to fix that. And as I said as well, in this case, everything is the same, but with a lot of our analysis that we do, projects that we work on, it's a case where we're taking stuff from different places, different websites where we download data from, getting things from different agencies or whatever it might be. It's going to be in a variety of geographic datum, WGS 1984 versus NAD 83, that kind of stuff. It's also the whole projection concept is going to be different. Some things might be in a state plane system, some might be in UTM. Here in California, it could be Teal Albers. There are a whole host of these different projections that can be used, as well as the datum that's utilized as well. So we want to make sure everything goes together, right? And it's a case too where we're not going to do it here like we have done. What we've done before is we'd just go in here and we'd find something and go, okay, I want this, and we'd select stuff and we'd be happy and hit okay. That's not going to fly for what we're doing. And the reason for that is that while this works to make a pretty map and to have everything kind of line up and look nicely, this is doing what we call, on-the-fly projection, where the computer itself it figures out, and based on what the data are initially projected in and what we want them to look like, right? Whatever projection we're doing here, it takes this information, it does the necessary math to make sure that everything lines up, right? That we, no matter what we select in here, that these roads and counties and states and the parks and all these different layers that we have, they're all going to line up beautifully, right? At least for on the display, right? On our screen. Right? It's doing the math, but it's trying to move quickly so that we don't experience any lag, any delay in seeing our data. So it does a quick and kind of dirty effort to reproject the stuff, put it where it needs to be, and every time we zoom in or zoom out or move around, it's going to do that. It's going to do the math. But the actual algorithm that's being utilized here it's not the best. It's designed for speed and not accuracy. So what we're going to do is, instead of doing this thing, we're actually going to project. We're going to change and actually produce brand new feature classes here that will all be projected into something that we want. All right, so that's the key step. And what that means when we do this, it means that any subsequent analysis that we're doing will be the most accurate analysis, or will result in the most accurate results, where we can really get down to some fine precision and ensure that what we're producing, what we're submitting to a boss, to some government board or the public or whatever, it's great. It's going to be accurate, wonderful results. All right, that's the goal. So to do this, what we're going to start doing is getting into this analysis ribbon, and there's a whole host of stuff in here. Some of these things we'll play around with today. Other things we're not going to touch in today or even in this class in general. There's an amazing amount of stuff that you have access to, and plenty of these tools. I mean, there are things I have never ever worked with. Maybe occasionally in some tutorial thing when I was learning, but to be honest, I mean, things like business analysis. I don't do business work. I'm not looking at that kind of stuff, so I don't work in that field, right? Whereas other things, I work in all the time. That's how it's going to be. So don't get overwhelmed with all this stuff. Feel free to explore, see what you can find here, but also try not to get overwhelmed. And in part two, to make sure you don't get overwhelmed, I'm going to walk you through just kind of the basic way to get to some of this stuff. So we're just going to click on tools right here. Let me get this stuff closed. Here we go. See, I've been playing around with stuff, so it looks a certain way. For you, this might look different. And we have a few different tabs up here, like favorites. These are things that we've used in recent projects. You most likely don't have anything in here if you haven't done this stuff, or maybe you do. I don't know what it looks like on your screen, but just in here, click on the toolboxes tab. And I just want to show you these toolboxes contain specific tools, right? Like this one here, quick export, quick import. These little hammers, that indicates a tool. All right, here we go. This looks good. We have within here, like this analysis tool box, we have the extract tool set. And then within there, we have specific tools like clip, select, these things here. We also have these scripts. And it's the same concept as a tool. I mean, for most of what you're going to do, you're going to run one of these things. You're not really going to notice a difference between whether there's a hammer icon or this little scroll thing next to it. But what it's saying is with this script is it's taken something like, I think they're all in Python, a scripting language, and put together existing tools and wrote the script out, right? Did the coding necessary to be able to do something more with it. That's effectively it. And if you continue on with GIS, you'll learn, I have no doubt, how to do this kind of scripting. It's very useful when you have repetitive tasks that you need to do. but there isn't some pre-made tool to do that. Right? So I've written stuff like that just because I know I constantly have to do this and this and this to a specific data set as part of my normal workflow. So rather than click, 10 different things and have to redo it, I can automate it. All right, make it so that I just click one time, one of these scripts, have something like this, and it makes everything just so much easier. All right, that's the difference in here. But for now, don't worry about this stuff. Okay, so in here, I mean, you might get to the point. I have this where when I was really working on this stuff, I'm very stubborn in these search boxes. I don't always and I like to know where stuff is. You're free to go in here, analyze stuff, see what's in here yourself, kind of commit things to memory, make notes, check stuff out. But as we're working here, what I'll try to do is do everything through this search box to get you used to it. So we are going to we're just going to type in project. Okay. And in doing this, typing this in, it's given us a handful of tools and scripts that we can use that connect in some way to this. So this first one, you can see project, projects spatial data from one coordinate system to another. Like that's exactly what we want to do. It's in an existing coordinate system, but we want to take it and put it into something new. So that's what we want. We have this project raster. We're just working with feature data right here, so we don't want that. We have batch project. This is actually what we're going to use, where it changes the coordinate system of a set of input feature classes or feature data sets to a common coordinate system. Okay? So with this, instead of having to go in and do it, for what do we have here? 5 things, rather than having to do this 5 separate times, we can run this batch project, and where it's going to automate that. And you can see this little script icon here. Right? So it's a case where, somebody realized early on that, man, it's a pain when I have to go in and do this one at a time. Write a script where we use this tool, but we automate it so we don't have to worry about it. We kind of set it once and sit back and it does all that work. And so that's what we're going to use. Another thing I'll point out, though, before we click on them, is this define projection, right, overwrites the coordinate system information stored with a data set or whatever it says. And this is if we don't know what one of these happens to be. And that's something we find quite a bit, especially when you're finding data online, downloading stuff, bringing it in. It might be a case where the projection information isn't stored with it. So that's just, I'm pointing this out because that's a useful thing. Maybe you can check the metadata and see, oh, okay, this was UTM zone 11 or something like that. And you can go in and actually define it so the computer knows what to do. We don't need to do that because everything is already defined. So we are going to use this batch project. Okay, so I just left click on that. And we have input feature class or data set. And we can go in and we can do these one at a time, or we can hit this little drop down guy right there. Okay, since we want to do all of these, we can just select this, what does that say, toggle all checkboxes. I left click that once, it just automatically grabs all of these, and I can hit add, right, to save time, to make it, to speed this up. Okay, then we have output workspace, okay, and I will, you know what, I tell you what, this was the geoprocessing, this is the one I put in Canvas. I made this geoprocessing basics project. I'm going to save it in there, and I'm going to hit OK. All right, so it's saying, take all of these, we're going to project them into something new, and we're going to save these new feature classes in this specific space. Okay? It's not a case where we're going to change the existing ones. We're going to change them we're going to turn them into something new. Okay, and then output coordinate system. This is key. Now, if I hit the drop down, I can select from something. Now, I don't want to do that because all of these are in, they're in the old geographic coordinate system. I don't want that. Also, the current map is set there, so I don't want that. Instead, I'll hit this little globe guy, right there, and it brings me into this familiar looking box, okay? And it'll let me choose something in here. Now let's see, I think I will do, since I'm going to work in California, I'm going to do state systems, and I'll go ahead and do this NAD 1983 California Teal Albers meters. Why not? And I'll hit OK. Let's see. Does that give me the four? Oh, this is going to be difficult. Come on. Give me a little. All right, I tell you what. Let's leave it. Let's see if this works. Okay, and I'm saying this because the datum is changing. This was WGS 1984. This one's NAD 1983. This transformation, so we'll see, but the help is being difficult. There we go. So to convert data between two geographic coordinate systems, datums, it's saying it's optional. It used to give you some examples here. Let me click this. And so what I can do, I just clicked on this question mark, and it brings you to Esri's website, and it gets into the tool itself. And this is, I mean, a real, a slick instructor would have gone through and checked all this stuff ahead of time and made sure that it was seamless and make it look like I know what I'm doing. But the reality is, quite often you get to a point where you're starting to do something and you're like, wait a second, I know there's this thing I need to do, I don't exactly remember, or I've got this question, I don't really quite understand what this one variable is, or whatever, right? What you want to do and get in the habit of doing is click on this little question mark thing to take you to the help, okay, in here. And it will, run through, explain the general idea, what these different parameters mean. Okay, it's not giving me a list. I can't remember all this stuff. All right, we're just going to go with it. We're going to hit run, and we'll see if it freaks out. And so it's thinking. We can see that down in the lower right here. Okay, and it might take a little while. Hopefully not too long, but I am doing a lot to this rather large data set, or a series of different feature classes here. So we'll kind of wait and see. In fact, what I will do... Oh, no, look, it worked. Look at that. Look how quick that was. Beautiful. I can view details to see what happens, and did it successfully, giving me all sorts of information in there. Well, let's see. Let's go into Catalog. And it was in this Geoprocessing Basics. So this is the new one. And let's just bring cities in. I'm going to change this to something big. Okay, so we can see the existing and all that. And it looks the same. You don't see any difference. But if I go in here to properties, okay, look at that. Look at that. It's saying, so what happened here is I went into the properties in here, and this is to, again, draw it, not to change the data itself, but to draw the map, right? To change the display of this thing. And now in the layers option here, it gives me two. I've got this WGS 1984 and the NAD 1983, and it gives, cities, fits in there, and I'm going to hit OK, and it changed it. I don't know if it's that obvious, but it changed how the data are displayed here. Okay, so what I'm going to do, here, and actually let me show another thing. If I click on data source, so you can see a handful of different, and this is, okay, well, don't worry about that. Let's skip that then. So I didn't have that set as beautifully. So I'm going to remove all of those. Okay, and I'm going to go back into Catalog, and I'm going to add this other stuff so that I now have the projected ones. And really what this means, I'm going to change the drawing order here, but what this means is that now the data are all in the same datum projected coordinate system. Again, it simply means any work I'm doing is going to be all the more accurate as I move forward. So kind of a pain to do, this extra little step, but it's something we always want to do and always be aware of the fact that we need to do it. Okay, so, and let me hit save for now. Now let me zoom out a little bit. And it's a case too, you can see, this is for the United States, all these different layers in here, because I've projected it into this California system. California itself looks pretty good, but everything else kind of goes off at a weird angle here, but that's okay. We're not going to care about the rest of the states. We're going to focus on just California itself. And there are a few things we can do with all this in order to do it. But what I want to demonstrate is this clip tool. It's the first real geoprocessing tool we're going to play with. And I say real in the sense that something that isn't just this projecting stuff, but really getting in and analyzing data, right? Not just setting the stage for that. So what I'm going to do, I'm going to right-click on states. Let's go to attribute table. A few different ways we could do this, but this works for me. All right, and so I simply want to work in California. And I can see, because it's close to the top here, thank you, Alphabet, I'm going to just select California just by left-clicking on this thing to grab it there. I could also do a select by attributes function here, which we've done before, right? Get into wherever it says state name equals California and go from there. All right, but I don't need to do that because it's there. I'm happy. All right, so I've got that, and I'm going to go ahead and close this. And just to make sure it's easy, I'm going to right-click on states, go to data, export features, and I'm going to save it in the same geodatabase, so geoprocessing basics. Awesome. Output name, I'm just going to call California. And you can see down here too, what I could have done, I could have just done this, I guess, and saved a step. Instead of doing the attribute table, just doing this, I could do, select where state name equals blah, 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 blah. But I don't need to because it's selected. So let me hit OK. Haha. And so I've got this right here. Let me go back up here, clear that selection. You can see. Okay, and we'll even make this just to make sure it all stands out. It's got a lot of these yellows and blues in here. Let's make, I don't know, let's do this guy kind of different. Okay, so you can see, I now just have this California shape right there. And I'm going to use that with this clip tool. Let me bring this down here. So I'll turn off states. In fact, to keep it from being too confusing, I'm going to right-click and remove. Now that's a good habit to actually get into what I always try to do when I'm working with this stuff and going through and doing new things. If I don't need a feature class anymore, right? And I don't, because I just wanted the state of California here, so I don't need every other state. Just get rid of it so you don't get confused as you're going through. All right, so now got that. I'm going to go up to analysis, go to tools, and I'm going to in here in the little box, the search box, I'm going to hit clip, and I'm going to go right there. Okay, and click that first one, clip. Okay, now with this, a few things. We have this Pairwise clip tool, provides enhanced functionality or performance. Intriguing. What this is, and you'll see this with a handful of these, this Pairwise deal. It's a way in which the tool runs, but it takes advantage of like the quad core processors that a lot of computers have. It's nothing that's going to change your end result, but what it's going to do is have your computer handling the analysis a little differently. If you're dealing with a massive data set and doing a lot of hardcore computing, this should be fantastic. This should help speed everything up. For what we're doing here, not a big deal. It's not going to be noticeable, the differences. So you might see stuff like this, and if you're ever, confused, again, click on these little, question marks and things to see what's going on. Now, this is nice. If I hover over this, it gives me this classic help window that ArcGIS has had for a while now, and I love this. And I love it because it's got cartoons, and it's very simple and helps my brain remember exactly what it is I'm doing. Okay? So with this, and if I click on this, I can go to the actual website, read more about it, but I like the pictures where it just shows input plus the clip feature, and then that arrow is your output, right? It's saying this is what it's going to return. So input is this larger data set. The circle is that it's like a cookie cutter, right? It's the idea that you're going to push this onto the data and cut out just the stuff that's within that clip feature. And because it's all connected to space and place and geographic location and all that, it's going to be, in the proper location. It's not just randomly throwing a circle on this stuff, but it's the case like what we're going to do. Our input will be like, we'll start with counties first. Okay, so that's our big field. Our clip feature is going to be California, and therefore our output will simply be those counties that fall within California. Okay, and that can help too as you're going through, if you're not exactly sure what one's the input feature or the data set, in here versus the clip features, you've got this little identify icon that shows up. But you can also, what I often do, if I'm dealing with something that I'm not quite sure, I can't quite remember, I hover over this and I look at the cartoon. So it makes sense in my brain. All right, so input. In fact, I totally forgot. What is this? We hover over this. The features to be clipped. So that means the big one, right? That big set. So I want counties. Clip features is going to be California. And then the output features or data set, it's just going to call it counties _ clip. Okay, so it's creating something new. And again, is an important thing to remember. I'm not destroying the original data set or forever altering it or whatever. I'm producing something new based on this whole level of analysis. All right, so counties, clip, and you can also check, where exactly is it saving it, make sure it's in that geoprocessing basics in here. So I'd have to do that, and I'd have to retype it, which is kind of a pain, but just to make sure, just to kind of rest easy that I know exactly where this thing is going to be. And I'm going to hit run. Look how quick that was. Awesome. And I've got it. It showed up over here. And let's also change this into, that color. Beautiful. And also let's to make sure it's really clear. Okay, so I've got the pinkish purplish color going on in here. Those are my California counties. Everything else was left out, just the stuff that falls within that state of California. Okay, and sure, I could have gone in and done the whole select by attributes to grab these counties, but sometimes that works, sometimes it doesn't. And that's a key thing as you're working with this stuff. So many different ways to accomplish what it is you're trying to accomplish. You need to think about what's the best one, either the fastest way to do it, maybe the most accurate way to do it, and the way that these things are going to do the actual processing and all that. Just what works for what you're trying to accomplish. Keep that in mind. There's no one way to do any of this stuff, although there are plenty of best ways to accomplish something for a specific task. All right, so let's just remove that right there to get rid of it. And I'm going to go ahead and to try to speed this up here, I'm going to clip a few different things. You can see the little X, it's because I got rid of it. But I'm also going to clip major highways. I'll just change this. I'll just call it highways clip. I'm going to hit run. Beautiful. I'm going to do cities. And I'll call this one cities clip and hit run. That did that. And then, oh, in the parks one, it's national parks and forests in here. And I'll call this one net parks underscore clip and hit run, because why not? Get them all. And then so I've got those. I'm going to remove that initial one. I'll remove this initial major highways and remove the cities, right? And so if I zoom out, you can see all that old stuff is gone. I simply have things within California. And that's going to just make life easier if I'm simply interested in what's happening in California, right? If I don't care about Arizona and Utah and these other states, but I'm simply working in a specific area, then fantastic. And what this does is not only does it cleans up, my screen when I'm working with it. I don't have all this extraneous data out there, but it also is going to speed up the analysis. The computer doesn't have to work on as much stuff in there, right? If it's only in a specific area. And maybe, like let's say I'm only interested in Los Angeles County, I could do this even further and clip it to the county itself, right? Same process. Maybe I'm interested in just LA. I could get the actual LA city limits, and you can see. So this cities, let's just label these right here, and I've got all the different communities of Los Angeles, and I have my one LA point. But that's not useful for clipping because that's simply a dimensionless point. I can't clip based on the point. I would need the actual city limit, some kind of polygon shape, right? So that's a key thing there. So that's not entirely, this cities as points isn't entirely useful from a geoprocessing or an analysis standpoint. It's just kind of more of a, it's a reference. It's a way to get a sense of what's where in the state. Okay? So there's that. We've simplified this stuff. Now, let's see. Let's try buffer. Okay? And the buffer thing, I'm going to just go here and do this. We can see this pairwise buffer is in this kind of, I guess this is like most often used or kind of, convenient things right here. I'm not going to worry about that. I'm going to show you how to find this stuff here. But again, multiple ways to get to this. But I'll hit buffer. And we have a handful of options in here. I'm just going to do the straight buffer tool. But the idea, see if we can get a cartoon, yes, is that we can take some kind of feature, an existing feature. In this case, we're going to do it for the roads that we have, okay? And we're going to draw what they call a buffer, but it's going to be a shape at some predetermined dimension. So like in this case, we'll do, we'll do 2 miles, okay? So what it'll do is we'll use the lines of the roads, which is this kind of bluish color on my screen, and we're going to have it draw 2 miles around each line. It's like in the middle right here, right? So it's going to be this kind of bubble balloon looking thing around there. And we get this, it shows dissolve type none. It means for separate features, you're going to have separate buffers, and dissolve type all means it's going to blend it all together. It's this dissolve tool or process. That's actually something else. That's another geoprocessing tool we can have where you can take, these different shapes and kind of blend them all into one thing. Like what we could do with our counties layer is we could dissolve that to turn it into just California itself. We get rid of the individual county lines in here and it just all kind of gets blurred together, if that makes sense. That's what dissolve is. But for this, I want to draw a buffer. As I said, we'll do 2 miles. We'll see what that looks like. All right, within here. So input features is going to be my highways. Okay, and this is giving you, just kind of generic stuff. Highways clip buffer. that works. In fact, one thing I often do, because I sometimes mess around with different buffers for whatever reason, is I'll do 2 miles in there. So I remember, yeah, that it's that's the dimension itself, right? Maybe I do 1 mile, 2 mile, and a 5 mile buffer. I have these separate things rather than having to go in and measure it. To be sure, I can just look at the name of the feature class. So I'll select miles, make sure that's that. All of these I'm gonna not worry about. You can look at the information here if you care about that. But I do want, let's see, yeah, dissolve all output features right there, so that it's not a bunch of, because this could be really ugly and messy. I just want it to be a nice buffer. Okay, so I'm going to hit run. We'll see how this works. There we go. Oh, gorgeous. Okay, and it gives it this nice little transparency in here, so we can see what's underneath. I like that touch. But what you can see here, this blue blob area, these are 2 miles around any of these major highways around, in this case, around Southern California, but it did it for the entire state. Okay, so this can be useful for a variety of reasons. Quite often, we have things where we have to do something within a set distance from something. So in this case, it could be we're doing some kind of analysis, cultural resource management, something I've worked in, where we need to look. We're going to maybe extend some off ramp on something, and we want to study an area within 2 miles of the existing highway to make sure any of this digging that we do isn't going to disturb some kind of cultural, artifacts, areas of importance, whether prehistoric indigenous Californians, historic or historical, settlements and things like that. So we would measure something like this, get a sense of what that area entails, and then start surveying it, start checking it. And we'd know exactly where we need to be looking because we have that, right? It can also be a thing of you can't have anything within, say, like 1,000 feet of a school, all right? Something like that, whether it's, tobacco billboards or sexual predators who convicted, can't live within certain distances of parks and schools and stuff like that. This is how you can figure it out, right? Just simply by changing with the linear unit here, is it 1,000 feet? Type in 1,000, change that to feet, right? 12 kilometers. 12, change that to kilometers or whatever. Okay, so there's another geoprocessing tool, and you can hopefully start to see how we can use this for types of analysis. And if it's not clear right off the bat, you'll get plenty of experience with this and examples over the next handful of weeks. Okay, so there's that. Another thing we can do, let's do this. Back here, we have the erase feature. This is what I like. It's fun to mess around with. It's kind of the opposite of the clip feature. Let me see. Beautiful. Okay, so it's a case where we're going to get rid of data. So you can see our input and our erase feature and our output. So the input would be that initial big set, but maybe it's a case like with this 2 mile buffer around the roads, maybe we have that, and within these different national parks and forests that I have here, maybe we want to remove this 2 mile thing from any of these parks, right? Maybe because we're doing some kind of study, some kind of analysis on things that are outside of 2 miles from a major highway, right? And again, you'll get specific examples as you work through stuff, but this will work for what we're doing. So I'm going to say, let's do our national parks right there. That's what we're going to look at. Our erase features will be the buffer, the 2 mile buffer, and we'll call it National Parks Clip Erase. Fine. That works. We'll hit run. Let that think. Okay, and of course, one annoying thing is, it seems, at least on mine, I'm assuming this is an ArcGIS deal. but it likes to keep everything roughly the same color, not the exact same color, and it makes it very difficult to see if anything actually happened. Let's do that. Oh, beautiful. So what we've got, let's turn that off. In fact, let's turn that off. So you can see, like where the buffer is right there, it's gotten rid of it, right? It's erased that. It's saying that this area, it's outside of my study area or whatever, right? But this one right here, this counts, this polygon. And what you sometimes get is these little slivers, right? So if I put this back on in here, it's just a case of that buffer just came up to the edge right here, actually went past it there, but came back down. This might be relevant for your analysis. It might not. It might be a case where you don't even worry about this specific little sliver of the park itself. You know, who knows? But say this is a case where doing that projection initially, right, where we took and we did the batch project and turned everything into the Thiel-Albers projected coordinate system that we have. This is where it's key, because we're making sure that with all of this, as we're getting really close and coming up to the edge of things and where we're starting to compare things, overlay things, we absolutely want to make sure that it's as accurate as possible and as precise as possible as we're moving forward. So that's why we do this. Right? And sometimes it's just kind of ugly and doesn't really matter. And we might, clean that up and throw it away from a final product or whatever. But at least we know that we're dealing with good analysis and making sure that we don't lose, say, a couple 100 feet of study area that might be key if we're doing something on endangered species or important geological resources or something like that. We want to do good work. So that's what's going on there. Okay, so that's erase. Let's see, what else can we play with? I'll do intersect, and then I think that's good, because that's another useful tool here. So in my geoprocessing thing, I just hit this back. Let's do intersect. Okay, and let me zoom back out a little bit. In fact, what I'm going to do, let's undo this erase, because that won't really work for what I'm going to do here. And I'll even turn off the buffer. Maybe I'm interested in where we have these national forests and parks. You can see with some of these, you have highways running through them. Others you don't. And you can also see, like up here, we have these weird gaps. And it really gets into the way in which we designate roads. It's not that you're driving into Death Valley or anywhere around here and then you just run to a spot where the road disappears. It's a case of it fits into this major highway classification on this stretch, and then this is a more it's a local road. It's considered something else. It doesn't have that same designation. So there's a road there, it's just not clear. And so it's also a case of this might not be the best data set for some types of analysis. That's another thing you want to look into. And maybe you need to get into a much larger data set, specifically extract the entire road itself running through an area, whether that's a major highway or not a major highway, right? So this is all other ways in which we start to mess around with data to conduct real analysis. But we're not going to worry about this as we move forward. We'll work with what we got because we're just playing around. All right, so this intersect tool, I'll show you here, is where we overlay two feature classes. So you have input and intersect feature, and you see the output. It takes where these two different feature classes intersect, hence the name, but where they're touching, right? And it's only going to give you those in return. Okay? And you might think, well, that's kind of like clip, kinda. But I'll show you where this can be, how this can be useful, when we'd want to use it, when I get to the actual output itself. And again, this pairwise thing, If you're doing, massive data sets, a lot of complicated stuff, maybe that's useful. We're not going to worry about that here. Okay, instead, we're going to take, what do I want to do? Let's do national parks. And we're also going to do the highways. And, you can continue on down here. This rank feature, it has to do with snapping and tolerances where stuff gets kind of close. You're effectively saying what's the really important feature class that we're doing and what's a little less important. And we're not going to worry about this stuff, but that's what you can do in there. Our output looks good. Attributes to join, all of them, right? We have other things, feature IDs, which gets, I think I talked about that FID field, just the unique identifier in there. We're just going to keep all attributes. I'll show you why. That's typically the most useful. And then same as input. Yeah, let's just leave all of this as is and hit run. Okay, and you can see, got this little brown shape here. In fact, let me make that a little bigger so we can see it. And let's go ahead and zoom in so you can see, right? It's where those roads are inside the parks. And you might think, okay, that's kind of like clip. If we go into the attribute table, okay, we have what we've maintained are both of the attribute tables from these features that we put in here, right? So we've got like the, in fact, let me, to show you right here, actually, let me do it this way. Bear with me. There we go. I'll show the selected one. So you can see it's in Death Valley over here, right? And it gives us all that information from that park. But then over here, it gives us the road information. So it's 190. That's the highway that we've got running through there. And so I know, and also, it's a state highway and all this different stuff. But I know when I'm looking at this, not just that it's inside, the specific area, but rather I know that it's in Death Valley itself, and I know the name of the road itself. So this is great when you're trying to compare, all these different feature classes, and you need to know two things. I need to know the roads themselves that are inside Death Valley, not just show them, but, let me know every single one that's here. Maybe I'm working on some kind of, land use thing, and I want to know things like, the geology, underlying geology. I want to know the vegetation. I want to know different land use types. Is this something that's been developed, or is it more, natural, undeveloped, or vacant, or things like that? So I can overlay all this stuff, and I can then query out things like, show me, Highway 190 and Death Valley, just that, and it's going to show me those lines in this case, or show me something that's on some kind of silty loam, and it's got this, grassland vegetation and, a variety of things, and it'll be able to pull that out. All right, so as you're working through with this stuff, and I'm simply trying to show you how to access these things in the exercise for this week. You'll play around with this stuff and have a more deliberate purpose behind it. But as you're doing it, think about, how is this useful? What might this be useful for in my own work, my own area of interest, right? Maybe you're working on, in this class or others, some kind of ecological thing. Like I was saying, looking at vegetation and underlying geology and soils and that kind of stuff. Maybe that's not your thing. Maybe you're, a criminal justice major and you want to get into, solving crimes. Think about, well, okay, what is it? Well, I don't really care about vegetation type or whatever, but what are those underlying things that might help me analyze crime patterns, understand what's actually happening, or do some kind of, predictive or preventative stuff or whatever, right? Think about how these tools work, because what we're going to do as we move forward, and what you'll definitely be doing with your final project for this class, which we'll be talking about, and I'll be getting into in detail in the next few weeks, so you can start thinking about this stuff before it's time to start doing it. But you're going to be trying to solve some kind of problem, right? Some geographic, some spatial problem. You're going to think, okay, where is the best place to, put something, right? Or where could I find this kind of thing? Or what's the pattern behind these different events that are taking place, right? It's some kind of question like that. That's what I mean by solving a problem. There's something that exists, or maybe doesn't exist, but you need it to exist. In the case of like, where do I put this business or this new school or something like that. But what you need to do is think, okay, got the problem. What's my workflow? How am I going through here and solving this? And a big part of that, solving these problems, is thinking about, okay, I've got these different feature classes. I've got data, but what do I do? And this is where we go in and we start thinking, okay, well, I'll need to use the buffer tool and the clip tool. I'll use intersect. I'll use this dissolve. You kind of go through and think, yeah, this is what I need to do to accomplish what it is I'm hoping to do. So I'm not trying to simply show you how to click some buttons and run these tools and all that, but I want you to be thinking about, okay, how can I use these tools to actually accomplish something? Okay? Okay, so that's just an introduction to this whole analysis ribbon, our different tools and toolboxes and all of that, the geoprocessing. Again, you don't have to turn in any of this stuff, do any of this stuff. There'll be other things to do this week and in future weeks, but this was simply to show you where things exist and give you a little theoretical background to why we do it. All right. Have fun, geographers. Until next time, have fun computing.